Namaskar. So, in this week we discussed about few two port parameters, precisely Z parameters, Y parameters, and then H parameters, G parameters, and then in last session we discussed about the T parameters, that is transmission parameters. Now, when the system is very large and complex, we cannot analyze simply by putting one two port network. So, in that case it is required that the complete system can be subdivided into multiple two port networks, and those can be connected either in series, parallel, or maybe in cascaded formation. So, today we will discuss about how we will interconnect various two ports networks and what would be the best options in a different topological conditions such as series, parallel, or cascading of the two port networks. So, let us start the interconnection of the networks. So, as we discussed that the large complex network can be divided into sub networks for the purposes of analysis and design. The sub networks can be modeled as two port networks. So, the sub networks which we create out of the large and complex network, we will convert them as a two port network and we will interconnect them to perform the original network. So, we can now say that two port networks can be considered as a building blocks, then that can be interconnected to form a complex network. So, as we discussed that interconnection can be either in series, parallel, or in cascaded format. Now, although the interconnected network can be described by any of the 6 parameter sets, what were those? We discussed about Z parameters, then we discussed about Y parameters, then H parameters, then G parameters, then transmission parameters and the inverse transmission parameters. So, these were the 6 parameters based on two port network we discussed in our previous lectures. Now, we can describe any interconnected network with the help of these 6 parameter sets, but there are certain set of parameters which may have a definite advantage. How? Let us take an example that suppose the network is in series, means the two port networks, these are whatever the sub networks we have created. If these sub networks are in series, then their individual Z parameters add up to give the Z parameters of the large network. So, in that case where we see that the networks sub networks are connected in series, it is better to utilize the Z parameters to find out the overall parameter of the larger network. Similarly, in the case when the two port networks are connected in parallel, in that case Y parameters can add up to give the Y parameters of the larger network. There may be some cascaded networks also, where the output of one network goes as an input to other two port network. In that case, individual transmission parameters can be multiplied together to get the transmission parameters of the larger network. Now, these three combinations, that is series, parallel and cascaded combination, are very important for the circuit analysis. So, we will see now how we can utilize these parameters when we interconnect the various networks either in series, parallel or cascaded manner. So, let us take first case that the network is series connected. So, if you see in the figure, these we have the two networks, one is network A and second is network B. Now, these two are in series because the individual voltages, that is V1A and V1B, add up to give the voltage of the complete network, that is V1. Also the current I1 which is flowing in the network A will also flow in network B, because in case of series network the current flowing through all the networks will remain same. So here we can say that the network is connected in series, because you are adding up the voltages to get the complete network. Now as we know that the total voltage V1 is nothing but V1A plus V1B, we will first write the individual Z parameter equations for both of the networks. For network A, what we can write? We can write V1A equal to Z11A I1A plus Z12A I2A. Similarly, V2A can be written as Z21A I1A Z22A I2A. So you can see from this particular figure, this would be the Z parameter equations of these this network will be the equation which we just saw. Similarly, for second two port network, that is NB, we can write V1B is nothing but Z11B I1B plus Z12B I2B. V2B is nothing but Z21B I1B plus Z22B I2B. Now if you see this figure, we can simply say that since the two port networks are connected in series, that means I1 is nothing but equal to I1A and also equal to I1B, because the same current will flow in both of the ports. Similarly, V1 can be written as V1A plus V1B. So these two equations we can use to simplify these four equations which we wrote independently for network A and network B. So what we can write, since we know that I1 is nothing but I1 equal to I1A and equal to I1B, similarly I2 is also equal to I2A and I2B, and V1 is V1A plus V1B. So we will put the values of V1A and V1B and simply replace I1A and I1B with I1 and I2A and I2B with I2. So when we find out the value of V1, that is V1A plus V1B, we will add both individual equations which we written for these two ports independently. We can write that V1A plus V1B is nothing but Z11A plus Z11B into I1 plus Z12A plus Z12B into I2. Similarly, V2 we can write Z21A plus Z21B into I1 and plus Z22A plus Z22B into I2. So now if you see these two equations, what you can write? You can write, if Z11, Z12, Z21, Z22 is are the Z parameters of the overall network. So if you compare the values of V1, V2 with the standard Z parameter equation, we can say that Z11, Z12, Z21, Z22 matrix is nothing but the combination of the addition of individual Z11s of both of the sub networks compiled as shown in the equation. So we can say that Z11 is nothing but Z11A plus Z11B, Z12 is nothing but Z12A plus Z12B, Z21 is equal to Z21A plus Z21B, and Z22 would be equal to Z22A plus Z22B. So what we can write? In short, we can write the Z parameter matrix of the overall network is the summation of individual Z parameter matrix of network A and B. So with this we can say that the Z parameters of the overall network are the sum of the Z parameters of the individual networks. So now whatever we discussed was for two port networks, we can extend it to n set of sub networks which are part of the overall network of the system. Now, if the two port networks are represented using any other parameter, say h parameter, what we can do, since we know that the networks are connected in series, the best thing is that let us first convert the h parameters into corresponding z parameters of individual networks, and then use the summation of the z parameters to get the overall z parameters of the network, and then when we get all the parameters of the circuit for a series network, that is the z parameter of the overall network, we can convert this z parameter again back into h parameters. So, this is applicable for any type of interconnection which we may have in the network. So, the same is for maybe y or g or any other parameter which you get from the sub networks. So, you can first convert them into the z parameters, then add them, and the final z parameter matrix can be converted back into h parameters matrix. Now, let us consider the second case in which the network is connected in parallel. So, here we have network A and network B. So, these are connected in parallel when their port voltages are equal and port currents of the larger network are the sum of individual port currents. So, that means that V1 and V2 is applied to both of the sub networks, and I1 is nothing but I1A plus I1B. Now, in this case the circuit must have one common reference. So, in this case this is the common reference for both sub networks. So, we will connect them together so that we get the common reference of overall network. So, when you connect all of them in parallel, so the common networks you will tie them together so that the networks the sub networks will be in parallel. Now, what we have to do? We have to use the y parameters equations to find out the y parameters of overall network. Since these two networks are in parallel, we will utilize first y parameters equations. So, what we can write for network A, I1A can be written as y11A into V1A plus y12A into V2A. Similarly, I2A can be written as y21A V1A, y22A V2A. Now, for the network B, we can again write the equations in terms of the value of y1b and y2b in terms of the voltages, that is V1b and V2b, in the same manner as we wrote for the network A. Now, when we see the figure, we can easily observe that since the both networks are connected in parallel, we can say V1 is nothing but equal to V1A and equal to V1B. Similarly, V2 is also equal to V2A and equal to V2B, while the current is summed up quantity of individual two port network, that is I1 is equal to I1A plus I1B and I2 equal to I2A plus I2B. So, now if we put the values individual currents in these two equations, what we get? We get I1 is nothing but the y11A plus y11B into V1 plus y12A plus y12B into V2. Similarly, I2 we will get y21A plus y21B into V1 plus y22A plus y22B into V2. So, now these two equations are the final equations of the overall network. Now, as we can write y parameter matrix of the overall network as y11, y12, y21, y22, when we compare these two equations with the standard y parameter equations and compare the individual parameters with these two equations, what we can say that y11 is nothing but y11a plus y11b, y21 is equal to y12a, y12 is equal to y12a plus y12b, y21 equal to y21a plus y21b, and y22 will be equal to y22a plus y22b. So, in short we can write the y parameter equation of overall network is the summation of y parameter matrix of individual subnetworks. So, the y parameters of overall network can be calculated as summing the individual y parameters of the individual networks. Now, again this can be extended to any n number of two port networks which are connected in parallel. Now, let us see the third case where the network is connected in cascaded fashion. Cascaded fashion means the network A output is given as an input to network B. So, if you see in this figure, we say that current I1 and V1 is the overall voltage and current of the overall network, and V2 I2 is the output port current of the overall network. Now, the I2A, which is output of network A, will be given as input, which is I1B to the network B. So, from this what we can say that V2A is nothing but V1B, I2A is equal to minus of I1B. So, let us write first the network equations for these two port networks. What we can write? We can write for network A as V1A, I1A are the input side vector equal to A, B, C, D of network A into V2A and minus I2A, that is the output vector for the network A. Similarly, for network B also we can write V1B, I1B as an input vector equal to ABCD parameters for network B multiplied by vector output vector of V2B and minus I2B. Now, from the figure what we can observe? We can say that V1 I1 is nothing but V1A and I1A, because V1 I1, that is the input vector for overall network, will be nothing but the V1 will be equal to V1A and I1 equal to I1A. So, what we can write? V1 I1 is nothing but V1A I1A. Similarly, V2A and minus of I2A will be equal to V1B and I1B, because I1 and I2 are in opposite. So, minus of I2A will be equal to I1B. So, we can write V2A minus I2A equal to V1B and I1B. Similarly, at the output side what we can write? V2 is equal to V2B and I2 is equal to I2B. So, V2 I2, V2 minus I2 will be equal to V2B minus I2B. Now, we have this information from the figure. If we see these two equations, what we can write? We can write that V1 I1 is nothing but V1A I1A. So, this can be replaced with V1 I1 matrix, V1 I1 vector, and then it is equal to V2A minus the ABCD parameters multiplied by V2A minus I2A vector. So, since we know V2A minus I2A is equal to V1B I1B, so this we can replace with V1B and I1B, and now we know that the value of V1B and I1B can be given by these two, the matrix of ABCD matrix of network B multiplied by vector of V2B minus I2B. So, what we can write? This can be replaced with V1 I1 vector, and then ABCD parameter matrix for network A multiplied by V1b I1b. Now, V1b I1b we know this. So, we will again replace V1b I1b with the ABCD parameters of network B multiplied by V2b and minus I2b. Now, V2b and minus I2b vector you can see that we found from the figure that V2b and minus I2b is nothing but V2 and minus I2. So, finally, what we get? We get the V1 I1 vector equal to the ABCD parameters of ABCD parameter matrix of network A. Similarly, ABCD parameter matrix of network B multiplied by V2 and minus I2. So, that means that if the network is connected in cascaded fashion, the ABCD parameter of overall network can be the multiplication of individual ABCD parameters of the subnetworks. So, when you compare, you can say that if the overall ABCD parameter of the network is like this, when you compare both of the equations, you can simply say that ABCD of the overall network is equal to multiplication of the individual ABCD parameters of network A and network B. So, in short, you can write that matrix T is equal to multiplication of matrix T A and matrix T B. T is nothing but transmission parameter, right, which is also called as ABCD parameter. This is basically the very important property for the transmission, the cascaded network. That is why makes the transmission parameters very useful in case of cascaded network. Now, one thing which we have to always keep in mind, that multiplication of matrices, that is we are seeing here, must be in the order in which networks N A and N B are cascaded. So, if B is following the network A, then matrix multiplication would be T A multiplied by T B, not T B multiplied by T A. So, this we have to always keep in mind. So, whenever we have very large network and it is connected as a set of cascaded 2-port networks, the T parameter of overall network would be the multiplication of all the T parameters matrices of individual subnetworks. So, if we say there are n 2-port networks which are part of the overall bigger network, all n T parameter matrices would be multiplied in that particular order in which the cascaded networks are connected. Now, let us understand these concepts, the interconnection of the network which we discussed till now with the help of few examples. Now, in this case, the figure, the Z parameters of one 2-port network is given, the Z parameter of second network we need to find out. Since these two are connected in series, we can simply take the Z parameters of the second 2-port network, because this is the second 2-port network you will see, and we can sum up these two Z parameter matrices to get the Z parameter of the overall network. So, first the task is that we know the Z parameters of the upper network. Next, we have to find out the Z parameters of the lower network. Now, if you compare this particular 2-port network, you can say it is a form of T network. So, we can simply write the Z parameters of this type of network as Z12 and Z21 would be the center branch of the T, that is equal to 10, and Z11 and Z22 in this case would be same, because here in T we can assume that we have resistances of 0 ohm. So, Z11 would be summation of these two and Z22 will be summation of these two, but finally Z11 and Z22 will remain same because we have only one 10 ohm resistance. So, what we can write? We can simply write Z11B and Z22B also equal to 10. So, in case of second 2-port network, let us say it is NB, we can compile the Z parameter matrix as having all the elements as equal to 10, and for the first for the first 2-port network we already have the Z parameters in hand. So, we can simply get the Z parameter of the overall network. So, what we can write? We can write V1 is equal to 22 I1 plus 18 I2 and V2 is equal to 18 I1 plus 30 I2. So, these two equations now we have got. Now, from the figure, if you know, if you see, V1 is the output port voltage, but before that we have one voltage source connected in series with 5 ohm resistance. So, what we can write? V1 is nothing but equal to Vs minus 5 into I1, because I1 is the current which is flowing through the port. So, what we can write? V1 is equal to Vs minus 5 I1. So, for the output port, V2 is nothing but minus of 20 I2. So, we have now two equations coming from the initial the given circuit conditions. So, V2 we can write a minus of 20 I2, or nothing but I2 we can write equal to minus V2 by 20. Now, we substitute the above two relation into first equation of Z parameters. So, what we can write? We can write V1 in place of V1 we will write Vs minus 5 I1. So, Vs minus 5 I1 is equal to 22 I1 minus, we replace I2 with V2. So, we simply get Vs in terms of I1 and V2. Similarly, from the second equation, if we simplify while putting the value of I2 is equal to minus V2 by 20, we get the value of I2, that is 2.5 by 18 V2. So, if we put this value the I1 value in this equation and simplify, we say that Vs is equal to 2.85 V2. Now, in the question it is asked that we need to evaluate V2 by Vs. So, when we write V2 by Vs, we say V2 by Vs equal to 1 upon 2.85. So, what we get finally is 0.3509. So, you can see with the given circuit you can convert them into 2-port sub networks, and since in this case the network is connected in series, we can utilize the Z parameters to find out the answer, that is V2 by Vs given in this particular example. Now, let us take another example where we need to find out the Y parameters of the circuit. So, if you see these 2-port sub networks are connected in parallel. So, we can easily find out the Y parameters. What we can do? We can find the Y parameters of individual sub networks. So, individual sub networks means one is this sub network and another is this sub network. So, if you recollect in case of Y parameters how we compile the individual elements of Y parameters, we can write Y12A is equal to Y21A is equal to minus of connection between left and right leg. So, that is minus of J4. Similarly, Y11A will be equal to 2 plus 4 J in this case, and Y22 is equal to 3 plus 4 J in this case. Similarly, for the second 2-port, Y12B is equal to Y21B is equal to minus of the resistance connected between two legs. So, that is minus 4. Y11B is equal to 4 minus J2 and Y22B will be equal to 4 minus J6. Now, we have got Y parameters of individual sub networks, what we can do? We can find out the y parameter of the overall network as summation of individual y parameters. So, when you sum up the individual parameters, we get y11 as 6 plus j2, y12 is equal to minus 4 minus j4, y21 also equal to minus 4 minus j4, and y22 equal to 7 minus j2. So, all these will be in Siemens because these define the admittance. So, now with this we can close our today's session, in which we discuss about the interconnection of various two port networks. So, in this session we can say that the various two port parameters which we discussed in previous lectures can be interconnected in any fashion to analyze the larger networks. Thank you.